Hi there, and welcome to another webinar. This is our 10th webinar on platform engineering, which means that we have spent 10 hours doing live streams on platform engineering. Quite a feat, and I think more than us, you guys, all the audience who have joined us for all the webinars, deserve a badge of honor from our side. So, if you plan to create one, do drop in the comments that you have joined all the webinars, and we'll try to give you a badge of honor for attending all the webinars. So while most of you might know me, in case you don't, I am Atul. I am your host for the webinar, and I work as a senior developer advocate at InfraCloud Technologies, where I help teams and individuals adopt open source tools, platforms, and technologies by means of writing blog posts, building POCs, and doing talks and webinars like these. Now, some of you might be like, hey, it's a new week, but then this guy is again here talking about platform engineering again. We are bored of him. How much of more, platform engineering we have to listen to? We have already explored a lot of platform engineering. Well, I would say yes, but not completely. While we did speak a lot about platform engineering in the past, it was majorly focused on from the point of view of a developer. So we spoke about how platforms help development teams, how it improves developer productivity, so on and so forth. But today, we are taking a different point of view. We are going to look at platforms from the lens of a platform engineer, how a platform looks to the platform engineering team and the larger organization. If you're joining me in this webinar for the first time, you can view our previous webinars by scanning this QR code that will take you to our YouTube playlist where you can watch the previous webinars. Now, having said that, it doesn't mean that you need to watch those 9 webinars before watching today's webinar. These are not related, but then it would be good if you want to watch them in your free time. And like you might have guessed, I'm not alone here. I always come with some wonderful guests. And today I have two such special guests whom I had briefly interacted with at KubeCon Paris. And we were like, hey, can we do something, in the future? And apparently things worked out. And today here they are. So let me bring upon my guest for today. I have Sam and I have Kyle from Dagger. Hey, Sam. Hi, Kyle. Thanks so much for joining in.
Hello. Thanks for inviting us.
Great. So Sam and Kyle, like I said, I met them at KubeCon, and I know a little bit about them, but I would like them to introduce themselves to all of you. So Sam and Kyle, why don't you go ahead and tell our audience about who you are, what you do, where are you from, and what do you like to do outside of work? So Sam, would you like to go first?
Sure. Yeah. So I'm Sam. I'm a co-founder of Dagger, and before Dagger, actually, we've been working on that project for about 5 years. And before this project, so my co-founder and I, Solomon and Andrea, we spent a long time building Docker. So yeah, to tell you more about where I'm from, I grew up in France. I've been living in California in the US for about 12 years. And outside of playing with containers and containerizing everything I can, sometimes I play guitar.
That's a pretty good combination. Yes, Kyle, go ahead.
I'm Kyle. I'm a solutions engineer at Dagger. And let's see, before Dagger, I have a background in all kinds of DevOps. Most recently, before Dagger, I was a release engineer at HashiCorp, and lots of different scales of DevOps and platform engineering, from large teams to small. Let's see, outside of work. So I live in the U.S. I've been half in the U.S., half in Canada for my life, and I enjoy mountain biking.
Wow, that's a pretty diverse panel, I would say. We have a musician who loves containers, and we have a mountain biker who is a solution architect as well. That's the way I like you to put it. So, like we have a diverse panel here. I would also like to know from you, the audience, where are you from, and what do you like to do? So put them in the comments whether you are on LinkedIn or YouTube, and let us know where are you joining in from. So before we move ahead, a little bit of housekeeping stuff. We would be definitely taking in your questions. So you can put your questions in the comments, and I would be asking Sam and Kyle during our discussion to help answer those, or probably at the end of discussion. And as I'm speaking, we already have a question in place around Dagger, but I'll come back to it once we start discussing Dagger. So I think there's a lot of interest already about Dagger. So we are starting on the right note. So moving ahead, like you all know, we are going to be talking about platform engineering. And if you have seen the previous webinars that we have done, what we have been doing is that at least I always try to bring up a different analogy to help you understand about platform engineering. So a couple of webinars ago, I brought an analogy of a kitchen and how a kitchen is similar to a platform that allows developers, aka chefs, to prepare good dishes based on properly guided recipes and good ingredients. In the previous webinar, I spoke about platforms like music concerts, because where your performer is the developer who is dishing out experiences for the customers, and then you have the platform team who takes care of everything from the lighting, from the sound, and everything else. Today, I'm going to talk to you about amusement parks. Now, fun fact, I have never been to an amusement park. That's not my cup of tea. But I'm sure a lot of you who have tuned in would have gone to amusement park multitude of times. And what do you observe essentially in an amusement park? You have lots of rides. It's a well laid out system where you have a section with water rides, where you have roller coasters, you have an area where you have food court, you have another area with restrooms and support services, and all of this is managed by a team who is ensuring that it runs completely smoothly without any issues. And that's exactly how a platform is, where your roller coasters and your services are different services applications that your company develops. The platform team is the team that ensures that everything within the amusement parks function without any issues. For example, they'll give you the base plate or the infrastructure with which you can build your applications. They will give you networking, they'll give you storage components, everything that you need to build your applications. So today's funda was platform engineering like an amusement park. But to give an actual point of view, I'll want Sam and Kyle to put their inputs on what they think platform engineering is. How would they define platform engineering?
Yeah.
Sam, would you like to go first?
Yeah, absolutely. So for us, it's interesting actually to talk about an analogy, because it's true that it helps people understand the difficulty and the role of a platform. We often talk about it internally as and actually externally to to our users as a factory. Actually, it's really the factory that builds your application. And you can see almost, think about the factory of a car, building cars, many cars during the day. Everything is super organized. Every machine has its role. Everything is automated. Everything you automate is automated. You can automate is automated, and it's usually pretty streamlined. I mean, in the industry today, it's when you're looking inside a factory, you know whether it's actually a very modern factory or an old workbench from 100 years ago. And we think that in software, when we started Dagger, it really looks more like the workbench in your garage today for most people than an actual professional modern factory. And the problem with factories is that everyone has different needs because everyone is shipping different products. And so that's why when we designed our product Dagger, we thought about bringing primitives to people instead of well-defined ready factory. Instead, we were thinking we need to push the best practices and the primitives that allow people to build very organized and very efficient factories very quickly. And so this is how we look at Dagger.
Interesting. I really like that analogy of factories and associating it with platforms and the workloads and how things move on. So we'll move on to the discussion. And one thing that all of us have observed nowadays in the modern landscape is platform engineering is gaining interest, and it's not because it's an hype, but then a lot of people and organizations have realized the true benefits of a platform. And here are some stats that I've just collected from the internet. These are some stats which talk about what are the benefits that organizations see when they try to adopt or when they want to adopt platforms. So increased productivity is almost 50%. So and then followed by better quality of software. So you really understand that how much these platforms actually affect your entire workflow and your processes that you have in place while you're shipping out features. Interestingly, there were more than 30 talks at KubeCon in Paris on platform engineering. And even as Gartner predicts, by 2026, 80% organizations would have a dedicated platform engineering team. And moreover, there was a co-located event which was Platform Engineering Day in Europe during KubeCon, and there's also a Platform Engineering Day that's happening at Salt Lake City, which is happening in November. So you know that it's not just a hype, and there are a lot of organizations and people involved in making platforms more accessible and making the journey a lot more simpler than what it is. And that is where we are contributing by bringing this platform engineering reference architecture ebook. And the whole idea about this ebook was same, that we want to help organizations and teams adopt platforms in a much easier way and a lot faster. And give them a blueprint as to, hey, this is where you can start your journey from. This is how you can build your platform. In this book, we have provided a lot of blueprints for teams to get started. We have given a lot of open source tool recommendations as well that you can adopt and plumb to your platform, so that your platform can have those capabilities. I won't talk much about it because I've been talking about it for the last 9 webinars. So if you want to know more, just scan the QR code and download the ebook. It has got a ton of information for you to get started. And when we talk about platforms, right, we always talk about capabilities, and these essentially are capabilities that your platform offers your developers. So, what we have done is that we have tried to bucket these capabilities into 3 areas. We call them develop, consume, and discover. So, develop are those capabilities that your developers use to build their applications or the services. So, things like service templates, workload specifications, pipelines. These are the tools that, or these are the capabilities that help to build the application or the service itself. Secondly, when you are building services or applications, you tend to utilize a lot of external services, to achieve a lot of functionality. So, you might have databases, message queues, caching systems. These are all external services that, you consume to build your application. And that's what we put in the consume bucket. And lastly, we have discover, which essentially are the ancillary systems that you use to make your platforms or your services better. So you have things like observability, you increase the visibility, have some monitoring added to it, some developer portals, so on and so forth. Now, why are we doing all of these things? There are a lot of answers to it, but one of the things that I feel, and a lot of you would agree, is that the way applications are developed and deployed today is completely different from how it was even 2 years ago. Forget about a decade. The technology is changing so fast that our ways of building and deploying applications are changing every month, if I could say so, because that's how things are changing. So earlier, when your application would sit happily on your server, today that same application is deployed to multiple environments and multiple platforms. There are some applications or modules which are relying on your on-prem system, which is a safe cocoon for your application and module, while there are other modules and applications that are out in the wild on the internet. So it's not only challenging to build such applications that work at such a large distributed scale, it's also challenging to handle such applications at that very scale, at that distributed scale where you have so many platforms and environments involved. So my question to both of you, Sam and Kyle, is what are the challenges you see from a platform engineering perspective, especially when it comes to building a platform that actually caters to the needs of the diverse environment and platforms that we have?
Sure. Yeah. Well, I think I clearly in the last few years, and you said it. It's not just the last 10 years. It's changing pretty much every year. There are more and more cloud services out there. More and more managed databases, managed queue services, paths also to deploy, like all the way from a backend function to a full stack, actually full stack app. And so the thing is, all of those services are good for developers because it makes everyone more productive. Now it's not really often that teams have to build infra services themselves. Usually you consume something that from a provider. And the headache from the platform engineer point of view is that, well, you have more and more services that you need to interact with, and they are more and more powerful, and you have more and more secrets manager to deal with, configurations format to deal with. And so the kind of things you need to automate grows over time and is more and more complex. So as the developers are getting more and more tools in their toolbox, the platform engineer has to automate more and more things. And so that's really the challenge we see. And I don't think it's going to stop. AI is actually bringing even more complexity to this, but it's definitely the same problem. The problem is you need to, in order to ship often and to mass produce your application from your software factory, you really need to have everything automated cleanly. And so that's really the problem of the platform engineer. And that also explains why a lot of those platform engineers over time built their own tools and their own custom scripts and automation here and there. And this is why platform engineering has been so messy in the last few years. Because the problem is it's just getting bigger and bigger. And so obviously we have solutions for it, but I won't go into it now. In a few minutes.
Sure.
Yeah, that's just to add on to that, to take it back to the car factory analogy. It's when you set out and you say, I need a factory that can build a car, and you have these clear outcomes of what a car looks like. It's not impossible, or even maybe not that difficult in an organization to build a factory that can make that car. But when that evolves and you have a larger, more mature organization, and you say, okay, now this factory needs to be able to build a minivan and also a race car. How do you make, that's the challenge, is making one factory that can make all of these different things with these different needs.
Absolutely. I think when Sam mentioned about the various tools that are coming into developers' toolbox and they are happy, I could not stop myself from quoting the Dagger docs, which actually mentions this line, and that has been stuck in my head ever since I read the docs a few months back. And that particular line there simply reads that a developer's dream is a DevOps nightmare. And that's exactly what you told. The more number of tools that are being added to the toolbox, it's becoming a nightmare for the platform team. So yes, I completely agree. The number of tools are increasing, and I think one of the technologies or tools that help us integrate all of those are obviously the CI/CD pipelines, and I think all of us use them in some way or the other. These are tools that help us automate a lot of things and connect them to things like container registries or secrets or even your deployment targets. But then when you are building a platform which actually deals with such multitude of different environments and different tools, how difficult or complex it is to build a platform that provides you seamless integration with all the environments that we have.
Yeah, I mean it's always. I mean, we said it. It's always a mess, and indeed, what I see in your slide right there is it's the orchestration piece. So it's not just about automation, but as soon as you automate, it's a behavior. So meaning, I know how to build my app, run my tests, interact with all the services that I need. Actually, the job is not over, and oftentimes you need to integrate with more complex deployment tools that will figure out whether your application is ready, the ROI rate is satisfying enough to continue the rollout, etc. And so yeah, it's just it's a very complex systems. And as Kyle also said it's sometimes teams have to build different types of assets, which basically forces you to not just have it work once for one type of application, but actually adapt to build different type of applications over time. And that's why the platform not only need to be automated and efficient, but it needs to evolve over time. And that's why we think that the platform itself needs to be programmable. Because at the end of the day, platform engineers are software engineers, right? And so, it's oftentimes better to have access to a programmable pipeline than for instance, a YAML configuration file that's supposed to answer all the problems. And so that's why we made Dagger programmable to basically make that possible, make this platform not just efficient for one specific automation, but also programmable to evolve over time easily. And so you don't have to reinvent the platform every time.
Interesting. Kyle, would you want to add something to it?
Yeah, no, I think Sam nailed it. It's all about, in this case, about unifying across clouds. It's about separating your concerns from the differences between those clouds. So you have to lean on your tooling and abstraction layers to do that.
Yes, absolutely. I think one of the things that we always discuss when it comes to platform engineering is the balance between flexibility and abstraction. And whether you talk about it from a developer's point of view or a platform engineer's point of view, I think that is a very critical, decision that has to be made by the platform team. When it comes to deciding the flexibility versus the abstraction, decision. Now, while we have been talking for the last few minutes, a lot of one of the words that we have spoken a lot is complex. We know that platform engineering is not simple, and especially with the increasing number of tools, it essentially becomes a lot more complex. And I think in today's world, especially in the last few months, I think the answer to anything complex is AI. I mean, if I have an issue, what I want to prepare for lunch, I will probably open a chat bot and ask that, hey, I have this 10 ingredients, tell me what to cook. Or, if I want to listen to some music, I'll turn to some Gen AI assistant and ask it to, give me some solution. So with AI being everywhere around us, from our mobile applications to my watch to iPads and laptops, I'm sure it's going to be there in some form or the other in platform engineering as well. And we have seen a lot of companies come up with tools that are actually helping developers improve their productivity. Talk about co-pilots and things like that. But then, how do you think we can bring in AI to platforms and make them more versatile? To say, what are your thoughts on that?
Sure. So, well, first of all, bringing AI in companies, and it looks like it's happening a lot nowadays. Is I think the way we look at it is it adds some constraints to platform engineering and to developers in the sense that there are just more characteristics you need to take into account for your platform, but at the end of the day, an AI app is an app, and it requires the same sort of automation and pipeline in order to automate the whole CI/CD and so we think that the problems are at the core the same, but in terms of the solutions need to adapt to a new set of constraints. So for instance, those constraints can be, well, we have a bunch of GPUs that we need to use, and so our app is using some, doing some inference on the model, and we use GPUs for that. Well, it means you also need GPUs to test everything, and so then you include some hardware specificities into your pipeline. Another problem can be the amount of data to deal with. So all models, even if you're not training one, you have a super large training sets usually that you need to pull. So imagine you have, I don't know, like tens of machines on your CI infrastructure. Well, it means you will need all of those weights, so all the model preloaded on each of the machines, so you can actually run your test and have access to GPUs only when you need to, because compute is more expensive there. So yeah, it just adds more constraints and more things to take into account. And it's a good example of what we were talking about earlier, like the platform needs to evolve. And there is we don't believe at Dagger into a platform that will solve it all. Like we give you something that's ready with a nice clicky UI where you can deploy all apps. You can give that to your developers and it will work 100% of the time forever. No, a platform needs to be programmable, and so that's why we provide the primitives. An example is sometimes last year we needed to add GPU support for Dagger, so you could actually use a GPU in a pipeline for running your build, your test, or anything. But our role is to provide best practices and primitives, but we're not the one telling people how to test an AI application, because it's very specific to your app. And so yeah, that's how I see it. And I think it's only the beginning. AI is huge today, and is changing the way people think about their businesses and their apps and their automation and their platform. But more things will come along the way, and so it's something that platform engineers always have to adapt and learn and evolve. So as well as the platform itself.
Interesting. Kyle, how do you see AI affecting platforms?
Yeah, well said. I think, I guess the headline of how I see it is that there's this saying that to a hammer, everything looks like a nail. And so what that means is, if you're really strong in this one particular solution, then you will try to solve everything in that way. But in reality, AI is really a tool to use for your platform, or really a whole category of tools, right? So you can't just throw everything else away and say it's all AI now. But if you just ignore it, you're also losing out on that whole category of tools that might help you build your platform in a better way. So I think that's the way I think about it, is it's another category that helps you build your platform, but it's not the only thing.
Interesting. I think that's a very valid point, Kyle, that you made. It's not the only thing available, but then it is something that you can definitely leverage to improve things, in your workflows. So yeah, I think we have had a good discussion, where we started by talking about the different environments that are available and how platform teams can build platforms, that can cater to it. We spoke about the complexity involved in, CI/CD pipelines, especially dealing with such diverse workloads as well. And lastly, we touched upon AI. And maybe a few months ago, if Sam would have told all of this, it would have made zero sense to me. But everything that he spoke today made some sense, because I'm trying a little bit in my free time to read about AI. So I know what inference servers are, I know what GPU nodes are, so on and so forth. So yeah, I think we will take our discussion to the next phase, which is the core of today's webinar, and we would be looking at Dagger. And I have just dabbled with it a little bit, but when they say, when you want to learn something, learn from the best. And I've got the best people in the house today to learn about Dagger. So I'll give them the stage. For the next 15 minutes, Sam and Kyle, the stage is all yours. Tell us about Dagger and what all it can do from a platform engineer's perspective.
Great. Thank you, Atul. So yeah, I will give you a short overview of Dagger and the different components of the platform, and then I will leave it to Kyle for a live demo. So if you move to the next slide. So yeah, the first problem we saw before we started building Dagger is that your local dev environment often looks very different from your CI systems, and so the machine and in the platform that actually automates everything usually is different from your dev environment, and so the end result is, as soon as you build your application, run your tests, everything works, you're satisfied with everything, you want to submit your code to to the rest of the team actually for review. And this is when your CI system traditionally kicks in with all the tests and integration tests and everything. And this is the time when you often, after pushing your code, you pray that it will actually work exactly the same than your local machine. And in order to make all of this work, you also have to maintain a large set of complex scripts and automation. So if you move to the next slide, so Dagger actually solves this by with several things. First of all, a Dagger pipeline is containerized by design. So every single thing you will run from your Dagger pipeline will run inside a container. And Dagger will orchestrate a graph of dependencies with each node is containerized. And the end result is, well, if you implement your test suite, your builds, all your automation, and it works on your machine, it will work exactly the same on your CI environment and on any CI systems you use, which means you can actually handle those pipelines to developers, and Dagger can be part of your development environment because it will really run exactly the same on the CI. And also it's programmable. So here, for instance, you see an example of a pipeline. It's a tiny pipeline. It's actually a function. So that's the small unit of a pipeline. It's written in TypeScript. And so the idea is you use the same language than you use for your application. And so here, the very quickly, because the Kyle will show you a better example. But here you see, well, actually moving to the previous slide, I will just mention something where it's building a Go project from source, running your test. So hopefully it's not too small to read. Build a container, publish this container, and at the end run a scanner using a tool called Trivy on that image. But the interesting thing is that the Trivy tool was not part of the implementation of this pipeline. And so if you go to the next slide, you will so actually the Dagger engine runs pipelines run functions, and within those functions you can either write your own code or actually pull modules like the Trivy example before from the Daggerverse. So Daggerverse is a service that we launched that is a catalog to easily find modules. So something we didn't cover in the previous conversation is that oftentimes pipelines are not reusable. All the automation that you build is so specific to your platform that you never reuse it. And so without that, making the code of pipelines reusable is very important, because when I use something like Trivy or even like a deployment tool, or I'm using Helm for deploying something on Kubernetes or anything, I don't want to figure out what version I need to use, what arguments I need to pass, how to configure it properly with all the dependencies that are needed. So I will create a pipeline that integrates with this tool, and I can create a module out of it and publish it on the Daggerverse so people can reuse it, and I don't have to redo the work myself. Another aspects of pipelines is the speed, obviously, and oftentimes when you automate, you run your pipeline, you often do the same things over and over again. So for instance, here in the screen, you see how to use what we call cache volume. So it's a primitive that Dagger exposes where you can create a volume, you can put anything on it, inside it, and you will the data will be persisted across runs. So in this example, I will put my Go packages inside a cache volume. And every time I will run, I won't have to reinstall all the Go packages. So think about node modules for a TypeScript or JavaScript application, or the pip install cache for Python. So every time having a cache that's persisted across run can be very convenient for making my runs much faster and saving speed. I mean, going faster on your CI systems means saving money, right? So it's an important aspect. We also built a service that is called Dagger Cloud, and so the reason why this is important is when you have a large pipeline that is doing a lot of different things, a lot of different operations. When something breaks, it's often hard to figure out why. Is it my test that's failing? Is it my build that is slow? Is there something that I'm relying on that's down, and so I cannot push my application? And so Dagger Cloud provides you an easy way to navigate into your pipeline and quickly identify what's broken or what's slow and why. And so the Dagger engine is open source and free to use, and along with it, you can basically sign up to Dagger Cloud, and it's also, there is also a free tier when you can use it and see this, test it yourself. So you will have a result that's close to what you see on the screen, where you see all of your steps, and you can navigate into your pipeline. And so that's the last slide before I handle it over to Kyle, but it's a recap of what I just explained. So that's all the different components of the Dagger platform. So you have the Dagger engine in the middle that's running all the pipelines, entirely containerized, either on any CI that you use on your local machine. It will run exactly the same. Dagger Cloud on the left, that's for visualization and looking into what's going on into your pipeline and easily debug it. Then Dagger provides SDKs to make the Dagger engine programmable. Go, TypeScript, and Python. We also have a set of SDKs that have been contributed by the community. For instance, Rust, PHP, Elixir. We have actually a list that's growing week after week, and month after month, I should say. and the Daggerverse, that's a catalog of modules. So you can basically grab any tools from it, so you don't have to write your pipeline from scratch. And so now I will handle it to Kyle for a live demo, and more interesting than me talking, I guess.
We'll see if I can live up to that. All right, so we're gonna Daggerize our little application here to see basically how Dagger works from a really basic lens. And so this is our production application, this static website. So if we're talking earlier about platform engineering is building car factories, this car is like a Hot Wheels toy. So we can start by saying Dagger init, and we're going to use the Go SDK for this demo. And so what this will do is create a module that sits alongside my application. And that'll let me start writing functions to do different automation tasks for us. So this generated a Dagger directory here with the main.go. And it pre-fills it with two functions that kind of introduce us to the Go SDK. So we have a function called container echo and a function called corrector. And so using container echo, for example, it takes in a string argument and returns a container. And so we'll talk about a little bit about the primitives that Dagger provides, like container and file systems and these things that let you build these pipelines. And so this function, for example, when we call container echo, it's going to use DAG, which is the Dagger client, and we're going to get a container from Alpine latest. And then in that container, we're going to execute the command, which will just echo the string arg that we put in. And again, this is just generated when I did that Dagger init. So I can say Dagger functions, and I'll see those two functions that were generated, like container echo. It's overlapping a bit there because of our zoom level, but that's okay. So now if I want to run this first function, I can say Dagger call container echo, and it has an argument string arg, and we'll say hello InfraCloud. And so now we're actually running this whole pipeline where we can see it actually get a container, and it happened really, really fast, but we can run it again. So the main thing here to see is that we return a container, and it said container evaluated. So the container is just a Dagger primitive type that we can do lots of things with. So if I call help on that, it'll show like all the different things I can do with a container, which is a lot. Like there's all kinds of stuff. But for this case, let's just say standard out, which will give me the standard output from the container execution. And there's my hello InfraCloud. So moving forward to actually Daggerize our production app here, we want to create that production artifact, which will be an Nginx container with our static website inside it, so it can actually run our website. So let's create a new function. And this is just extending the myapp struct here, which is our module. And we'll call it web. And this will take in a directory because we want to pass in our source that we're going to put into this artifact. So we'll say directory. And again, this is another Dagger primitive type directory, and we'll talk a bit about the things that you can do with that. And this will return a container. And that container will be our production artifact. So again, like I mentioned, it's going to be an Nginx container. So we can say return dag.container from Nginx. And then I mentioned we want to mount our production application static site into that. So that's going to be our production artifact. So autocomplete helped me out there. So we can say with mounted directory. So it's going to, again, take a directory and mount it at a specific path in our container. And this user share Nginx HTML is like the default path for Nginx to serve a website. And again, that source is the Dagger directory. And so if we run this function and we want to put our index.html in there, so we can say, if we look here, this is where our index.html is. I can say Dagger call web, and we can ask for help first. And it'll tell us that we have an argument source, and that's a directory. That's a required argument. So I can say source is my current directory, so just dot. And again, we'll get container evaluated. So again, there's lots of things that we might want to do with that. And we saw all the different options before. So one thing I could do, for example, if I'm trying to debug what's going on with my build, I can say terminal, and this will actually just open a terminal in this container that we're building. And I can cat, let's see, index.html. And so there's our file. If we just look in that directory, we can see that we mounted our whole directory inside that. Some other things we could do with containers, we could run it. So let's say, again, I'm developing my application and I want to run the container so I can see what it's doing like it would in production. This is cool because we're using the same code path that would push to production to actually like run our app locally. So if I say as service now, and I say the service is up, and I want to say ports, so by default Nginx will be on port 80. So I want locally, I want it 8080. And now that'll run. and build our same artifact, and we can see that the service is up. It's giving us some output. If I open a new terminal and go localhost 8080, we can see our web application is running. And in addition to running this, of course, we can push our container somewhere. So I could say publish to a specific address. So let's say ttl.sh. So this is ttl.sh is like a registry you can use for testing things. So it'll push that up there. And now we've got like a fully qualified URL there. And we could say, fighting with my terminal here, we could pull that image and we could say Docker image inspect, boom, and look at the image we just pushed. Lots of interesting stuff in there, I'm sure. And so to take this a step further, we're talking about primitives to build your factory. With a container, of course, we can do lots of things that we just saw. With the directory, there's a lot of flexibility too. So from our command line, if I want to say, let's go back to our terminal one here. So source, I passed in my current directory, but Dagger can also turn any Git URL into a directory type as well, right? So I could say github.com, and we'll take the Dagger repo, for example. And we look at this, and then I say, let's see. So now we've got the Dagger repo in here. So all that is doing is just turning this Git URL into a directory for us instead of like a local file path. And you can take that even one step further to chain different things together. But real quick, before we look at that one last thing, to expand your toolbox even further, you've got container types, directory types, lots of other stuff in the core Dagger API. There's also this Daggerverse that Sam mentioned, where there's all these modules that people have built that do lots of more complex things like integrate with different tools. And so now your toolbox is expanded to include all these things, regardless of what language they're written in. You can import them into your project. So I could say, let's just grab a random one, kubectl, and I can copy this install command and run that. And that will install this as a dependency for my Dagger project, which I could then, once it completes there, start immediately using within my function. So we'll give it a sec, but we can look at the functions available for this module, where we can actually, let's see, this one looks like it works with EKS, and there's just the CLI. We could get that in container or execute some things. And so while that's running, let's just open a new one real quick. And the one last thing to show here is that in addition to being able to pass in directories as Gitrefs, we can actually call modules from Gitrefs as well. So if I wanted to look at Dagger's actual CI, I could say Dagger-M. Now I'm specifying a module other than like my current working directory. So I say github.com Dagger, and just say what functions do you have, plural. And so this will run and look up the module at Dagger and say, oh, we can do lots of things like run all the checks. We could get a CLI, dev engine, SDK. And so these are all the same functions that run in Dagger CI that you can use locally to develop Dagger. So you don't have to, again, going back to that push and pray, you don't have to write your code and push it to CI to have the proper version of the test run. They're all defined within these functions, and you can run them locally the same way they run in CI. And that one finished, we could say, within this, there we go. Within this, there is dag.kubectl, and now we've got lots of things we can do with that module that we just installed from the Daggerverse. And just to mention the traces, all those things I'm doing locally. Again, if I have this pipeline run locally and I want to ask my teammate, why did this run fail? Here's all my runs in CI on this page. I also have my local runs, so I could go to this one and maybe share it with my teammate and say, okay, this one worked. So we'll pick one that failed. This one's a great example because I had a typo. So I could share this. Well, maybe it's a bad example because there's no output. But I could share this one and ping my teammate and say, hey, I ran the CI check and it failed, and I can actually link the run rather than copying and pasting output. And from here, I can dig into specific parts of the pipeline and see exactly what happened. So yeah, that's the super quick, high-level overview of what Dagger can do. Adds more tools to your toolbox and lets you run CI the same locally and in CI.
Yep, thank you, Kyle. And if you want to get involved, the easiest way is to go to dagger.io, and there is a quick start in the docs. We have a very active Discord community as well. So you can join our Discord, ask any questions, discuss with other platform engineers. Hopefully you will like it. And feel free to ask any questions then, about what we discussed here and what Kyle showed also. It's pretty easy to go through the doc and go through the similar demo yourself with your code. And so, yeah, that's it. Thanks for the opportunity, Atul, for talking about all of that.
No, thanks to you. I think, Kyle, that was a wonderful, demo. In such a short time, you showed us how Dagger works and what all capability it has. I think one feature that I particularly liked was around the fact that the later part where you spoke about traces, where I could just share it with my team and ask them, tell them that, hey, can you just figure out why it failed, and they are able to see those traces and tell me what went wrong. I think that really brings into the ethos of platform engineering, especially from a collaboration point of view, where you have things centralized and where your different team members can collaborate and quicken things. Now there are quite a few questions that I have got in the comments. So there is one person named Ali, and he has had a couple of questions. I think one of these questions was around where does Dagger fit in Kubernetes. So I'm just flashing it on the screen. I guess you did touch upon it a little when you showed the kubectl thing from Daggerverse. I think that really gives a taste into where exactly Dagger would fit in. So I think, Ali, you probably have an answer for this. You can head to dagger.io and explore more how Dagger actually integrates with Kubernetes, because it actually does, and that's what Kyle essentially spoke about. There's a follow-up question, which again from Ali that I am flashing on the screen. He's asking about Dagger functions. So he's asking, where would you publish Dagger functions within the company firewall? I mean, is artifact supported? I'm not sure, but I think he's asking about if you have a private repository or something. I mean, is that a place where the functions can reside? If I'm correct.
Yeah, you just need, so when you need to store functions, you just need you just store the code of the function itself. So you just need like a source repository like Git anywhere. We are actually adding support for private Git repo as we speak. So I think it should be available in the next release. So yeah, the idea is you just store the source code of the function, and when calling the functions, Dagger will build it automatically along the way and will cache the result of the build. So you actually don't need to store it to store the built result of the function, just the source itself.
Got it. I think that helps. So there's one of my friends, good friends, Ram, has a couple of questions. He has a two-part question. The first question that he is asking is, what's the Dagger part to adding SIG-store signatures to build and workflows? Fairly technical question and I know from a person like Ram, this question is expected. So how does that work with Dagger?
Yeah, so I'm not an expert of Sigstore myself, but we have someone in the community that is building chain loop and is using Dagger for integrating chain loop with Dagger. So I think that I would probably recommend to look into that integration. I'm pretty sure that will answer the question for interacting with Sigstore signatures.
Got it. And I think his second part question is particularly targeted to Kyle. Which keyboard is he using?
It's a great question. Do we have like an hour left? Here's a quick look at it. There you go.
Probably you can put the name and link to the keyboard in the LinkedIn comment section. I think Ram can figure out if he wants one from there.
Perfect.
Great. So I think we have time for one last question, and this is from Rohin. He is asking, is it possible to enforce a policy in Dagger? I mean, for example, image name that we are using. Is that possible?
Yeah. So I would assume with the question, I will extrapolate a bit just to imagine that we're talking about image and a name for containers that you are building as part of the rest of your application. And it's true that we often saw that sometimes the platform team needs to enforce certain policies. And so in that example, the image name itself. Well, so the thing, hopefully that the demo and the demo answer that question in the sense that if you have you will program your build pipeline. So all the automation for building those containers, you will program them yourself using Dagger. And so here you can implement any enforcement that you want. If you want to take like an argument that's called app name from developers, and from the app name you actually generate the image name, that's totally doable. And so you can really implement all the checks that you want.
Oh, that's why you're muted.
Yeah, you're muted.
Sorry, I realized now. Yeah, so thanks a lot, Sam. I think, Rohin, you have got your answer from Sam, and everyone else, Ali and Ram, I think, all the questions that you asked, Sam tried his best, and Kyle also to answer the questions. But in case you have any more questions, these guys are around in the community on Twitter, on LinkedIn, or you can just head over to dagger.io, join the community. And I think they would be more than happy to answer your questions and queries. And with that, we come to an end of this 10th webinar, completing 10 more hours of live streaming platform engineering discussions. And today was absolute fun. Thank you so much, Sam and Kyle, for spending your time here and educating all of us with platform engineering and Dagger as well. So thanks a lot for being here, and I hope we would be able to do something really more exciting in the future as well.
Thank you.
Yeah, thanks.
Great. So then, thanks everyone. Keep an eye on our social channels. We would be coming up with another webinar quite soon. Until then, if you want to learn more about platform engineering, head to our website, scan this QR code. You know the drill. Head to our YouTube channel. You have all the webinars, or reach out to me, Sam, Kyle, or anyone else to know more. So until then, have a great evening, have a great day, and have a wonderful time. And see you all on the other side. Bye-bye.